A questo punto inizia la trasmissione. Tutti i partecipanti sono in grado solo di ascoltare.
Ora, adesso però bisognerebbe che tu facessi un po' silenzio.
All right, it's 10 o'clock. I suggest that we start for the sake of time, and in the meantime, people can still join. We are about 80 people now. And good morning, everyone. Welcome to the Scientific Writing Seminar organized by the Virtual Physiological Human Institute. For the next 2 hours, we will hear from Professor Marco Viceconti. He's a full professor at the University of Bologna, and he's one of the key figures in the international community of in silico medicine. I believe we will all learn a lot from him. A few technicalities before we start. Please keep in mind that we are recording this webinar, and as attendees, you will all receive a link to the YouTube video when it's ready. We will also share the slides with you, so you can enjoy the webinar, basically. And if you need a certificate, please send an email to Federica from the Institute. We will type the email address in the chat in a few minutes. And please also keep in mind that we will have time at the end for your questions, but we would like you to type your questions in the chat, and I will pose the questions at the end. Yeah, as we are too many people, it's better to have the questions written and estimate the time we need for them. And I don't want to take further time, so it's time for the real deal. Marco, floor is yours.
Thank you very much, and thank you for the kind introduction. Could you please confirm that you can see and hear me, and I don't know why this window popped, and see my slides? Everything is fine?
Yeah, it works.
Good. Good morning, everyone. This is a long-standing tradition. Before in Sheffield and now in Bologna, every year I offer to all PhD students in the university who work around scientific teams, 2 seminars, one on scientific writing and the other on how to give a presentation, a scientific presentation. This year, for a technical glitch, I had to repeat this seminar around June. So discussing with the director of the VPHI Institute, she suggested that we could actually transform this into a webinar. So this is a bit of an experiment. I mean, if this works well and you know, it makes sense and you all find it useful, please let us know, and we might consider actually to make this a standard webinar series that we repeat every year for both seminars. Okay, so let's get started. First of all, some disclaims, and we start with a very famous disclaim from a guy called Dennis DeSallo. If you don't know who he is, you'll find out in a minute, where in the first issue of the Journal de Scavan wrote, "We commit to report the ideas of others without guaranteeing them." What do I mean? This is not a presentation about science. It's a presentation about practice, and like every practice is an accumulation of experiences, mine and of others. Okay, so there's nothing guaranteed. You will probably find some of the things I'm telling you useful, some other probably not. Some won't work for you, but that's the nature of the beast. I also put some citation. What we have to learn to do, we learn by doing. This is Aristotle. Of course, the point is, a lot comes from my own meandering experience as a scientific writer of over 300 papers. And then last but not least, I passed this from books from Hippocrates, Galen, and anyone else. By experience, the Greek teacher have composed them. This is Paracelsus. So let me declare my primary sources. These are very old books, but you know, basic fundamentals was an interesting topic in the 90s, much less now. So I'm not surprised about that. These are amazing books. So if you can find them, you know, in a used bookstore or something like this, I strongly recommend you buy. In particular, the book from Roger Day, How to Write and Publish a Scientific Paper, Cambridge University Press, is an amazing source. Okay. Good. Why do we publish? So when I do this lecture in a teaching room and I do interaction, I usually start this as a question, and usually a lot of PhD students reply with motivation that can be summarized with the American expression, publish or perish. Essentially, if you don't publish, your career in research will not progress. This is a fact, but this is not the primary reason we publish. The real reason is because this is science. What do I mean? Let me explain using a famous koan. If the bell tolls, but there is no one around to hear it, did it produce a sound? The answer is no, because the sound is not the generation of the pressure wave. The sound is the perception of that pressure wave. So if there is no one listening, there won't be any sound. There will be a pressure wave, but no sound. Okay, and the same is for the scientific method. If you lock yourself in your lab and discover amazing things, but you won't tell anyone, that is not science, because the scientific methods require that every discovery you make, every exploration you undertake is communicated to your peers, and scientific truths emerge from this communication. So it is really because of science that we publish, okay? Now, of course, communication implying comprehension. So the very first requirement of every scientific paper is that it has to be understandable by whom? By your peers, okay? So here we go into the question of language. First of all, scientific communication is not a novel. Papers have to be as short as possible, but not shorter, to paraphrase a famous quote. Journal of Bacteriology, instruction for authors said the best English is that which gives the sense in the fewest short words. This may or may not true for in terms of good English, but what really matters is that by being essential in your writing, you minimize the probability of being ambiguous, of being misunderstood. You have to be essential and precise in your writing. But of course, you don't have to exaggerate. A fundamental book for my generation is the Hitchhiker's Guide to Galaxy. And at one point, you know, they tell the story about this civilization that builds this enormous supercomputer and ask it the question of life, the universe, and everything. And after years of competition, the answer is 42, which is probably right, but nobody would understand what it means. Okay, so you have to be synthetic, but not too much. The other thing that is important in this audience is that many of you will write in a multidisciplinary domain. And typical are biomedical engineering, but not only. You have to keep in mind that multidisciplinary journals have a multidisciplinary readership. So the definition of who is your peer is a bit more complicated than in a narrowly specialized journal. Okay, so clarity requires an extra effort here. What about the English language? Well, if you're not a native speaker like me, I would advise you to shell out £7 or £1 if you're using Kindle to buy this little booklet. The Strack and White is the Bible of non-native speakers who need to write in English. Everything is essential to know on how to write in English is there. Best £7 I ever spent in my life. Okay, we already mentioned earlier the scientific method. What is the scientific method? Well, there are a number of definitions, but one that I like very much, proposed by Wilson, is the scientific method is a process by which scientists collectively and over time endeavor to construct an accurate, that is reliable, consistent, and non-arbitrary representation of the word. So collectively is the key word here, okay? How do we go about the scientific method? Well, first we observe a phenomenon, we describe it, then we formulate an hypothesis that could explain that phenomenon, and then we start to design and conduct experimental tests aimed to disprove this hypothesis, to prove it wrong, okay? And this has to be done not only by the researcher who has formulated the hypothesis, but more importantly, it has to be done by many other independent experimenters. And if this hypothesis resists all these attempts of falsification over the years, eventually we start to believe that that hypothesis may actually be true. Okay. Okay, there is a citation about Galileo here, and the point that I'm trying to make is that already Galileo understood that the use of mathematical language offer a precision in the formulation of hypotheses that makes them potentially falsifiable. That is very important, because if I say today I'm happy, this is not a falsifiable hypothesis, because no one in the universe can know how do I feel except me. So this cannot be independently falsified, okay? So the use of mathematical representation, in addition of being to some extent efficient, in my opinion, has also this substantial advantage, okay? However, again, multidisciplinarity, we must accept the fact that not all our peers are familiar with the mathematical language. So we have to choose wisely when to use this particular language to express our ideas and hypotheses. Okay, how did we came about with the scientific method? Overnight? No, it's been a long journey. A journey that started in the Islam community, the so-called Islam chemistry in North Africa, long before anything interesting from a cultural point of view was happening in Europe. Okay. Here I put some important dates, okay, of this mini history of science, okay. Roger Bacon, 1200, very important observation, hypothesis, experimentation cycle, very essential key point in understanding the modern scientific method. Joachim Braser, of course, 1300. The introduction of the printing press by the Gutenberg brothers. Why? Because without printing, there is no wide circulation of ideas. Without wide circulation of ideas, there cannot be really science. So until we didn't have the printing press, science could never really start. Natural philosopher were like a very elite club. So it was something for a few, where science is for everyone. Okay. And then, of course, Galileo Galilei, sensata esperienza necessaria dimostrazione, sensible experience, necessary demonstration. So the relation between experiment and logical deduction. Okay. And then, of course, René Descartes introduced formally what today we call the scientific method. As this chronology developed, scientific publishing started to consolidate, okay? One very important book in this story is Il discorso e dimostrazioni matematiche attorno a due nuove scienze of Galileo Galilei. As you probably know, Galileo was persecuted by the Catholic Church, and he was for his idea and his writing, and he was forbidden to do any further writing, any further publication. And he abided to this promise for a few years, but then his head was full of new ideas and he couldn't resist. So he started to write this book overnight in hiding. And then when the manuscript was ready, he gave it to a trusted friend who rode by horse from Italy up to Amsterdam, which at that time was the only place far away from the influence of the church where this book could be published. And in fact, it was published in 1638. I invite you to read the footer of this cover, which is the original cover of the book. If you can read, is in Leida, which means in Leiden, appresso gli Elsevieri, printed by Elsevier. So when we discuss about the dominance of Elsevier in scientific publish, remember this cover. There is a reason for that, okay? This is considered by many the beginning of scientific method. So this is, in a way, the first scientific publication, strictly speaking, okay? But what about the first journal? The first scientific journal, according to the historian of science, is Le Journal des Savants, published in the first issue in 1665 by Denis de Salo. So Denis de Salo was a Frenchman who was the editor of the first scientific journal. How do we define a scientific journal? Well, you'll see later there are some criteria to define what is technically known as a shelf journal, which is separated from what we call gray literature. Okay, we'll come back to this later. But the point is that this is accepted by all historians of science as the first scientific journal, okay? The first number was published on January the 5th, 1665, just a few weeks before the first number of the Philosophical Transaction of the Royal Society, which was published just the same year on March the 6th. Now, if you're familiar with the complex relationships that there are between British and French historically, you will understand how this has made very happy my fellow friends from UK over the years. But anyway, the good news is that Le Journal de Scavan, which was later renamed in Le Journal de Savant, unfortunately was suspended in 1792 during the Revolution, whereas the transaction has been published continuously uninterruptedly from 1665. So Journal de Scavan is the first scientific journal ever published, but the transaction are the first journal continuously published. Okay, the oldest, the journal which is in the longest in publication. Here is the cover of the first issue of the Philosophical Transaction, which is preserved at the, it's in London in a museum. I think it's in the museum part of the British Library. Yeah. The experience of a Royal Society, it's an amazing, amazing history. If you have time, spend some time to look into it. Remember, science didn't exist. There was just this bunch of people who were interested in nature, and they understood that they needed a more systematic and organized way to investigate nature. But they didn't call it science, strictly speaking, yet, okay? And I mean, some of these people are people like Christopher Wren, Robert Boyle, John Wilkins, Robert Hooke, and I'm sure all of you resound these names in their mind because we study their work and their results. These are amazing scientists, and they formed this society initially as a private thing. The idea was that they understood that in order to improve their way to investigate nature, they had to sit down and discuss their idea and criticize each other idea. Only from this debate, science, the knowledge of nature, what we call science now, would progress, okay? It's only later on that the Royal Society became the Royal Society, so received a royal charter and became a much more institutional organization, okay? But it started as a grassroots, spontaneous initiative, okay? Okay. If you look how scientific articles were written between the beginning of the story, so mid 17th century, until mid 19th century, essentially there were two types of articles. One was the experimental report. Essentially, one would do like a diary and say, I did this and I observed that, then I tried this and I observed that, then I tried this and I observed that. I always find absolutely fascinating that every time I ask a young student to do their first attempt to scientific writing, usually what comes back looks like that. So it seems to me that this is the most natural way for us to tell somebody else how to do science. But it's not the most effective way, and we'll see why in a moment. The other way to write papers was letters, and this were usually single author written by a very senior professor, and they would discuss very broad arguments, okay? So it was an exercise of authority, some ex cathedra speech, okay? things started to change around mid-19th century, primarily because of Pasteur. Now, Pasteur was working around this crazy idea that the corruption of flesh was not caused by the special nature of organic material, but it was caused by the fact that some external living agents, too small to be seen in naked eye, would arrive and start the corruption process. How in heaven he came to this idea without a microscope, I don't know, but he was a genius, okay? But of course, a lot of other people disagreed with him, and they sustained what was called the spontaneous generation. So the idea that organic material, organic matter had something special, so they had life in it, a sort of vital principle which separated organic matter from inanimate matter. And so even when you took a pound of flesh from a living creature and you leave it on the desk, eventually the life principle would rot this flesh and worms would appear, and life would proliferate. Now, in order to prove his idea, Pasteur tried to achieve, with a very limited technology at that time, vacuum, because he realized that if he could isolate a chunk of flesh into something as close as possible to a vacuum, corruption would not happen, which would confirm his idea. If I prevent this little invisible things to come in, corruption doesn't start. So this was very important to him. Of course, anyone who wanted to prove him wrong would have to repeat the experiment, doing the sealing not so well, leaving a tiny hole, and then of course the corruption would happen. So Pasteur started to write this paper where he obsessively described in crazy detail every single step he was doing to prepare his experiment. And this brought us what we call the material and method session, okay? So the systematic description of the material and method started there. And this was a substantial change that eventually, in a few years, evolved in what now we call the IMRAD structure. Why I'm going to talk about the Sputnik? The Sputnik was an important space mission from the Soviet Union, 1957. The first satellite, the first flying object was put in orbit around the Earth. This thing terrified the Americans because they imagined a rush for the space and a weaponization of the satellites, okay? And so the Cold War, that in those years was its crazy highest, became the space rush. The idea was whoever colonized the space first will win the Cold War. It didn't go like that eventually, but that's what they believed at that time. So in all the Western world, there was a dramatic increase of research funding. Until the mid-50s, scientific research was a very, very small community, largely underfunded. Nobody really cared much about science. But the space rush gave a dramatic impulse to science, in particular to technological research about material, engineering, physics, and so on. All of this flood of funding meant that more people started to work in research. Scientific publications started to increase. The number of papers that were published started to increase. There was a need for control and revision, so we started to have more rigorous peer reviews. And in 1958, just 1 year after the Sputnik was launched, was created the Institute for Scientific Information, or ISI for short. You probably don't know who they are, but you know for sure their most important product, the citation index. They invented the impact factor. So that is where bibliometry starts, essentially. because the Cold War, the space rush create big science. And big science creates all this huge volume of publication, the bibliometry, and so on, okay? So as scientific literature consolidate, it starts to structure itself more rigidly. And it gives some definition of what a primary publication is. This is the definition of the Council of Biological Editors, but it's an accepted definition by everyone, I would say. So we call a primary publication, a journal, which include enough information to understand observation, replicate the experiment, and evaluate the intellectual process. It has to be accessible in a permanent way. That means that to be a shelf journal, to be a primary publication, a journal has to have one copy of every issue they publish ever. So that means that the transaction have a copy of every single issue they published since 17th century. Okay, of course, some of them are preserved in museums, but in theory, if you have a very strong reason, you can go to the Royal Society and ask to consult number 3 of the transactions. Okay, because if you don't have permanent access, you are not considered a primary publication. It has to be available to the community. So it's not enough that you say, yeah, I have a copy in my safe. No, there has to be a mechanism where scientists can access of any copy, okay? And here is a very delicate point. It has to be accessible without restrictions. This has never been the truth, okay? For many, many years, the main restriction was economic. The access to scientific publication was based on fee, with various fee models. These fees were kind of acceptable for developed countries, were impossible to achieve for developing countries. So this was a restriction, okay? But what I think what they have in mind here is more, you know, you cannot make available a journal but saying, I will not let any Chinese to read my journal, or any tall person, or any woman, or this type of restriction are not allowed. It has to be universally accessible. Okay. The other thing, the third requirement is it has to be indexed by a secondary service. What is a secondary service? PubMed, which was originally called the Index Medicus, okay, or other similar secondary indexation services, okay. Everything that is not a primary publication is a secondary publication. This includes review papers, conference reports, conference abstracts, okay, with a special category for conference proceedings. Why? Because here there is a big difference between scientific community. For example, in engineering, medicine, biology, in general, conference proceedings are not considered very high. The idea is that accessing conferences is relatively easy. You go there to present preliminary ideas, but really the important step is when you submit your work to a peer-reviewed international journal. But this is not true for everyone. For example, in computer science, some peer-reviewed conferences are much more prestigious than any journal. I don't know, if you work in computer graphics, having an invited talk at SIGGRAPH is a big deal, really a big deal, okay? So in this case, the conference proceedings are really full length, fully, severely peer-reviewed publications. So they absolutely are equivalent to journal. So it depends on the community you're working in. Here there are some rules from the Council Biological Editor, okay, to be simple and concise, Make sure that the meaning of every word. Use verbs instead of abstract nouns. Okay. Always seek out and try to eliminate weak verbs like occurred, short, caused, produced, achieved, was observed, was noted. Avoid vague verbs such as markedly, fairly, quite, rather, several, very much. So all, if you want to say a number, be specific, okay? Break down cluster. I mean, this is a good rule also in English, but it's particularly important for the clarity of writing in scientific papers. What else? We tend to use a lot of jargon, especially acronyms, especially in more biological oriented research, okay? I mean, sometimes if you're not a specialist in that field, there are papers that are impossible to read. The title contains 7 acronyms, and you don't know what they mean, and it's really frustrating. Okay, so in general, you should limit the use of jargon, acronyms, and useless abbreviations. Spell out as much as you can. And if you have to use an acronym, spell it out the first time you use it, always. Don't pretend people know what YKZ or whatever means, okay? Call the same thing with the same name. This is very important. A good friend of mine used this thing he called it the terminology dictionary. When he started to write a paper, every time he used a keyword in the text, he writes it in a separate file, and he goes back and forth checking that he always called the same thing with the same name. Consistency is the keyword here, okay? If you're a native speaker, remember that you're not expected to write or to review assuming that everyone is from Newcastle or wherever you come from. International English is a language on its own. It is based on English, but because English has so many variations around the world, you have to be neutral. I remember still vivid as a young scientist where I got a paper back full of revision. At that time, revision was done by pen. So you could visually read pen everywhere because the reviewer decided to correct my Americanized spelling in an English spelling. So he corrected every word that in his opinion I had misspelled. That is wrong, okay? Non-native speaker, be aware of the caveats of your own language. For example, if you're coming from a Latin language like me, be careful, for example, with pronouns. In Italian, we use a lot pronouns. In English, it makes the sentence very ambiguous. For a number of reasons, it's much more difficult in English to understand who you're talking about. Okay, so you have to spell it out. We even use implicit pronouns. We don't even say she did, but we start to say did this, and it's very, very difficult in English. Okay, there are false twins. For example, the inverse meaning between sensitivity and sensibility, moving from Italian to English, and so on. Okay. When the grammar checking word says that the sentence is too long, it is too long. We are verbose. Latins are verbose. English require a much shorter sentence, and scientific English even more so. Short sentence, to the point, precise. Okay. Be aware of things like autocorrection. Word automatically correct double capital letters. So megapascal become that horrible capital M, lowercase pa, horrible. So make sure that you exclude all these things. Again, US versus UK spelling. Who cares? Spell how you feel comfortable. It's okay. And if a reviewer claims, you say, are you joking? Who care about that? It's not important. The only thing I would suggest, be consistent. So choose whether to use a UK English spell checker or US English spell checker, and then be consistent throughout your paper. Don't switch from one to the other as you go. Okay, what is the IMRAD structure? IMRAD stands for Introduction, Method, Result, and Discussion. It is the structure that I present here below. Title, author, abstract, introduction, methods, result, discussion, eventually acknowledgement, references, figure and tables, and caption. So let's go into one by one each of these. The title. The title is very important. For example, take this title, Preliminary Canine and Clinical Evaluation of a New Anti-Tumor Agent. It sounds like the dogs were evaluating the streptovitachine. Of course, it's not the case. It was tested on dogs, but the title is ambiguous, okay? The purpose of the title is, given a research question, what is the answer? A title must be specific, syntactically correct. It has to contain all the keywords that characterize your study. It should not be a phrase. It should be completely free of acronym and abbreviation. If you cannot describe in 10 words your work, you're not ready to write a paper about it. Everyone who worked with me had heard this sentence at least 20 times, and it's a very unpleasant sentence to hear, I know, but it's bloody true. It's absolutely true, trust me. This is a delicate topic, authorship. A lot of friendships were broken because of this in science. There are a number of criteria. In some communities and in some country, the less author there are in the paper, the better it is. So when they see these biomedical papers where the 100 authors, they go crazy, you know. Because ideally, it should be only your name. That would be perfect, okay? There are some domains where, regardless of the order you put the name, when the journal is published, they sort in alphabetic order to avoid any discussion, okay? But it's interesting because in some bibliometric system, for example, the one I deal with in my research hospital infrastructure in Italy, you get a different score if you are first or last author, or if you are in the middle. So this would work, no? In some system, there is a very big insistence about first authorship. So essentially, only the paper you wrote as first author matter. Everything else, you were a parasite, which is not true in general, but that's the attitude, okay? In some community, honestly, you see 50 names for work that was clearly done by 2 people. So it's clearly that, you know, everybody is hitching a ride, you know, in a way. I don't know. Here I reported the scheme that we use in my group, the criteria that we use to build authorship in our paper. I'm not pretending that this makes sense in your organization, in your group, in your university, but accept, okay, the message is accept the fact that this is a local convention. So try to understand what is the convention of your community on one hand and of the place where you're working right now. Abstract. I usually write it last. After I finish to write the paper, the last thing I do, I write the abstract because I design it as a sort of a summary of the paper, okay? But this is not always true. Some friend of mine like to write the abstract first because it's a sort of a blueprint for the paper to be written. An abstract should be less than 250 words, devoid of any bibliographic reference, written in past tense, so work is being done, so it's gone. It has to be the mirror of the text. This is a very important concept. Nothing should be only in the abstract. Everything you say in the abstract should be repeated in the main manuscript, okay? And again, it should be devoid as much as possible of acronyms and abbreviation, okay? There are a number of structures that are proposed for abstracts. For example, here, one that I report here, the so-called informative abstract. Some journals actually, in the instruction for authors, give specification on how you should organize the abstract, so pay attention. Introduction. So, this is a citation that I'm sure nobody of you understand because it's too old. But in the 60s, in the 70s, there was a popular TV show in America called Columbo. It was a typical murder mystery series. But what made it different was that the first scene of every episode, you would see the murder being committed. So from the beginning, you knew who the murderer was. That was not the point. The point was how the Lieutenant Columbo would actually go about to frame the murderer, okay? What I'm trying to say is don't try to create suspense. State from the beginning what is your main result. Be clear, be transparent. Don't expect the suspense is what you've done, not in the expectation. Okay. There are two major styles for the structure of an introduction, and I have to say I'm extremely partisan for the first one. It's the so-called 4-paragraph structure. Okay. I'm sorry, I need to interrupt for just a second because I need to move. Apologies. Okay, here I am. So I was saying the structure that I prefer is a 4-paragraph structure, which is why answering this question is so important. So why should we care? Second, what the other have already answered around this question, okay? This is all a citation of things that have already been published that you present in present tense, because having been published, they are now facts in the system of science. So they're not from the past, they are always from the present, okay? Third, why all these answers that are already been provided by your peers are not enough. What's missing or what's wrong, okay? And this brings you to the aim of your work. What is the exact thing you want to achieve with your paper? Why is important? What the other said? Why that is not enough? Aim of your work. 4-paragraph, everything is clear and to the point, okay? As I said, this is not the single structure. There are other styles, but this, in my opinion, is the most effective. Ultimately, the introduction has to explain two key questions. Why do we care? Why is important? And what is the question? If your study is the answer, what is the question? Sometime you can use this idea to to explain the organization of the introduction. It's called the introduction pyramid. So you start from the huge importance of the subject, the broad knowledge of the subject, some doubts that are left on the subject, one research question, okay? 4-paragraph, 250, 500 words. This is a fantastic introduction. Very difficult to write, very difficult to build. One of the most critical steps in writing a paper. But if you get it done right, the rest of the paper, it will be so easy to write because the framing is clear. You have no doubt what next. Okay, material and methods. If you are a young researcher who is spending a lot of time doing things with your hands, this is usually the part that comes easier to write because you know intimately how you've done, which instrument you use, which version of the software, etc. Okay, the idea of the material and methods section is that anyone else in another lab similarly equipped should be able to reproduce your experiment, okay? So you really should never intentionally omit critical information. This is not the patent office. When I hear sometimes people saying, "Oh, how did you do this? Oh, this is a secret." No, there's no secret in science. That's not the point. You're not building your competitive advantage. Go in industry if you want to do this. It's fine. There are other domain of knowledge where this is perfectly fine, but not in science. So never withdraw intentionally an essential detail. But on the other hand, give only the information that are indispensable to replicate the experiment. Don't tell me what color was the hood that you used to do your cell culture, because I don't care. It's not important, okay? One interesting problem is this. Say that you or somebody else already wrote a full paper describing in crazy detail a new method, okay? How do you, and then you want to use that method again in your new paper, how you describe it? So one extreme could be, we use the method of paper eggs citation, but that forced the reader to take and go in that paper to find out what that matter is, okay? That's not okay. So what I suggest is that you find a sort of a middle ground. So if a method has already been described extensively in a previous study, in a previous paper, you provide a shortened version of the description. So we use method X, which is made of this approach with this instrument. For further information, for more detail, please refer to citation, okay? The two parts, material and methods, separate what is being studied and how we're studying it, okay? So what is being studied? What is being examined? The materials description are typically of two types. You can refer to generic material. For example, we use a silicone rubber seal, or we can refer to a specific. So, for example, we use Silast Boston Ink USA. Okay, both are appropriate or not, depending on the context. I mean, it's if there is any reason why you should spell out, I don't know, for example, silicone rubbers differ for the additives that they include, okay? And if you're, for example, you're using silicone rubber to confine a cell culture of some kind, different additive will interfere with the cell culture and produce different results. So in that case, the exact brand of the silicone rubber might actually be very important. If you're just, you know, sealing a bowl of water to keep your specimen wet, who cares? It's silicone rubber. It's not important. So it depends on the context, okay? The methods are about what has been done to answer the research question, okay? If you have a complex method, it makes sense to use subheadings because they make it more readable, okay? But in general, you have to explain what has been done. So why it has been done. So what the scope, how it has been done. So the real method, and very important, how has been analyzed. This might mean, for example, to explain which statistical method was used to elaborate your data, or which filtering algorithms. I don't know, but the last part usually of the material methods is about the analysis of data. As I said, it makes sense to use subheading in material and methods to make it more readable. You can use topical sentences, for example, saying, using an animal model, we examine the effect of blunt trauma, blah, blah, blah. If you start like this, you have at the beginning of a sentence the word animal model. So someone who is looking for the explanation of the animal model has an immediate pointer at the beginning, okay? Or again, to prepare the specimen for testing, we did this and that and that. Again, someone who is looking for the instruction how you prepare the specimen will find, okay? Okay, when you cite the literature, especially if you're saying things like no one has ever investigated this, or no one has ever used this method before, I strongly advise you to introduce a standard conventional sentence, which is, in author's knowledge, no one has used this method. That because it's custom, and also because if a reviewer comes back and say, well, this is a paper of 1975 where you already used that method, you look a little bit less like a fool, okay? The other thing you might cite are personal communication. These are very, very odd things that shouldn't, but sometimes, I don't know, the guru of separation of cell from tissue reveal you the secret of how they're, and this thing has never been explained in any paper. How do you cite? You don't want to say this is my idea because it's not, but so you use this personal communication. So you state whatever whatever you want to state, and then you put between bracket personal communication. Virtually never you are allowed to state your personal opinions. Let's be honest, nobody care about your personal opinion, or mine for the matter, of anybody else. It's not about you. But so the cases where it makes sense to report a personal opinion are really, really, really limited, okay? Okay, material and methods are always written in past tense because you're describing something that you have already done, but there are a few exceptions, okay? For example, the verb to show depends on the structure, in the sense that if you're referring to a previous work, you say Smith showed that the use of this jig was more reproducible. But if you're saying the table one shows, you use the present because the table one is actually showing now, okay? The other thing is, a fact is always put in present sense. So you don't say the T students show that my results were statistically significant. If they were, they are. So they are statistically significant, okay? Albert Einstein was quoted to say, if you are out to describe the truth, leave the elegance to the tailor. What does it mean? It means that when you're talking about results, you have to stay on the essential. Provide just the result. It is everybody, we all made the same mistake. you find in result piece of the material and method, piece of the discussion, piece of the introduction, everything. Just keep the bloody result, only the facts. If it is how you've done, it has to go back in the material and method. If it discuss what the result means, it has to go in the discussion, only the result. And I know why we all do this, because after you work for 1 year, you finally write your paper, and all this work and misery and effort and sleepless nights, and then your results section is 3 lines. And you say, this little. Yes. If those 3 lines contain very important result, that's fine. Results don't have to be 20 pages. They are very short, usually. You spend a lot of time and space to describe your method. You might use a lot of space to discuss your result, but the results as such are very short, okay? There are a few tricks. For example, how do you handle when the method of choice depends on the result? So essentially, you had 2 methods to do the experiment, okay? So you tested, you obtained some result. Based on the result, you choose the first method, and then you continue the study with this first method, okay? And you discard this. How do you explain this? Because it's a loop between material and method and result, no? So how can you, in a narrative of a paper, describe this circularity? Well, I usually consider this result that was used to choose the method as a preliminary result, and I put in the material and method. So because the goal was not to achieve that result, that was only an ancillary result that we used to choose the method. In the material and method, I said we had to choose the method, so we compare method A and method B, and you describe them. For method A we got this, for method B we got that, and we choose method A, and that's it. And that's the material and method. And then in the result, you actually put only the real result that you got using method A. The other thing is, make sure that you don't fall back on the diary observer. Nobody cares how you got to a result. I know that before you got to that final setup, you tried 300 combination, and that took away 1 year of your life. But nobody cares. I'm sorry, it's rude, I know, but nobody cares. Just tell what is the good final approach. Don't explain the crucible that you went through to arrive to that final result, okay? Remember that this is not hiding facts, okay? You're simply hiding the process you arrive to them. This is very important, okay? All the steps in the scientific method are ancillary to the generation of the hypothesis, the falsification of those hypotheses. That's what really matters. How you went about it, much less, okay? If you have multiple results, how you present them? Well, typically in decreasing order of importance. So you start with the result that is the most important with respect to the aim of the work, and then the second most, and so on. If in the aim, in the introduction, in the aim section, you actually spell out 3 sub-aims, and each of them it has a result, then you should follow that order. So there is aim 1, aim 2, aim 3. In the results section, present first the result to answer aim 1, then the result for answering aim 2, and then aim 3, okay? Don't be ridiculous with statistics. I mean, it's a famous joke, 30% died, 33% survived, and the third mouse ran away. This is not statistic. This is a joke. Statistic is a very serious science that says, for example, that there is a minimum sample power below which concept like mean, standard deviation, etc., makes no sense. So be aware of these things. And if you just don't have enough specimen, don't pretend you do. Accept the fact. If you have 3 results, report your 3 results, and then it will be up to your peer reviewers to decide if those 3 specimens are enough or not. How do you report numbers? My rule is few in the text, many in the table, a lot in a plot. Okay, it's very simple. Never duplicate the same result. So don't repeat in the text what is written in a table. If you need for this course to do this, use a conventional mapping. For example, I don't know, in the table you report all the values. In the text you say the average value was something, okay? Or you give the absolute value in the table, and in the text you refer as a percentage, okay? But never repeat the same number in 2 places. Figures, this is something I've been repeating a million of times in my career to all my coworkers and students. The way you represent the data is the result. If you choose a bar chart over a pie chart, that is a different result because the choice of the representation convey a different message. If you're putting 2 graphs, one next to the other, the Y scale have to be the same, because by putting side by side, you are inviting the reader to compare the 2 graphs. So the reader will assume that the Y-axis are the same. And if they are not, this will be very confused, and so on and so forth. Representation is the result. So choose the representation of your result wisely. If you're not sure because you're young and experienced, go in the literature. If 20 papers on the same topic represent that result with a standard representation, don't be creative. Use the same standard representation. It means it's accepted by the community, and everyone who reads your paper will immediately recognize because they are already familiar with that representation. Try not to use figure and tables as subjects in sentences, okay, like as we've shown in figure 2, blah, blah, blah. And it's not better. It's better to show, we shown blah, 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 between parentheses, figure 1, okay? In this world of digital, the problem of quality is less important, but they have to be high quality figures because they have to be printed. Remember the text, when you shrink down an image, so say that you have your picture printed on an A4, you know, and everything is perfectly readable, but then when that picture will go into the paper, it will probably shrink down into a box which is a quarter of that size or even less. Remember that text shrink down more quickly than other visuals. So if you do this, a text that is perfectly readable at A4, when you reduce to the quarter, you cannot read the text anymore. So in preparation of the shrinking, you have to put a larger font than you would normally use, okay? Okay, so how do we map question and results? Like this. So there has to be a relation one-to-one between question and result, okay? Whereas method, you can use a method to produce more than one result, okay? But there has to be this type of mapping. And mark it in terms of order, in terms of subheading. Help the reader to navigate the maze of your research. Discussion. This is difficult. This is probably the most difficult part of writing a paper. point is always the same. If you are working in a clear context, if you understand exactly what the problem is and why, what is your question and what are the answer, writing the discussion is really, really easy. It comes with minimal effort. If you realize that you're struggling to write the discussion, it probably means the context is not clear. You should go back and think the fundamental. How do you organize the discussion? Well, an approach that I use, which is quite popular, you will find in many papers, is you start by repeating the question that you wrote in the aim. So you copy and paste the last paragraph of the introduction as first paragraph of the discussion, but you change the tense from the present to the past. So if there was the aim of the study is to understand what causes osteoarthritis, in the first paragraph of the discussion is the aim of this study was to understand what causes osteoarthritis. Okay. Then you provide the answer based on the result. Okay, so this was the question, this is the answer that we offer. And you slot in all the various results that were reported in the results section as they become functional to give that answer to that question. Okay. Once you've done this, what is the question? What is the answer? Then you go about the comparison with the literature. Now, there are two possibilities. Other studies that look in the same direction agree with you. And then that's easy. These results are in good agreement with what already found by John, Frank, and that's very easy. Or a little bit more convoluted, but still relatively straightforward, you get a confirmation by deduction. So John did observe this, but because this caused this, this somehow indirectly confirmed the fact that I found this other thing, okay? So you build an argument using literature and some deduction, okay? Then there are the papers that contradict your conclusion. So you found A, somebody else found B. Now, in that case, whereas in confirmation, you simply say, my work agrees with John and Frank. In this case, you cannot simply say, my work disagrees with John and Frank. You also have to say where they disagree, and more important, why they disagree. Yeah, and probably you don't really know why, but you have to make a guess. And usually the best shot is in the methodological aspects. Okay. I mean, if you've done your homework, when you started to do this research, you had already read that paper, okay? And you probably criticized that work, and you said, well, I'm not going like this. I'm using a viscoelastic law. I'm using a much higher resolution sensor. You've made some experimental methodological improvements, and that usually is a strong argument. So you say, I found A, John found B. The reason for this discrepancy is that he used a low resolution sensor, but when you use a high resolution, all these details come evident and hence the difference. Okay. Very important, always has to be there. You have to state the limit of your study. Okay. In my experience, there are two types of young researchers. The one that are incapable of seeing any limit in their work. So when asked, what are the limits of your works? None. My work is perfect. And those, and I have to say, this second category is the most common, which I call the self-fustigating, which write leave criticism to their own work so compelling that you are tempted to say, okay, but then if your work is so bad, why should you publish it? I mean, trash everything and start from scratch. So the point is, the limits are not you doing the review to your work. The limits are acknowledging that every work has some limitation. But as you acknowledge the limitation, you have to explain why, in spite of those limitations, your results allow you to answer the research question, okay? Because if this is not the case, then you know, you have to go back to the bench. You're not ready to publish, because if your study has such a big limitation that your results are not good for the purpose, well, you have to go back, remove the limitation, and do it again. Okay, so it's important, but you don't have to be overzealous. Sometimes it's useful at the very end to elaborate some theoretical implications or derivations. So because this result, now we can, you know, infer, we can speculate something else. And usually it's nice to close with one single conclusion supported by a list of evidences. You have to be wary of factual relationships. I don't know if you know the joke about the worm and the gene. So in this Irish county, there was this big problem of alcoholism, you know. So the school teacher, the first grade school teacher, decided to do a very strong educative experiment in her class. So she comes with a jar full of gin and a big fat living worm wrinkling around. And then she said, look, children, what happens when I put the gene, the worm in the gene, okay? And of course, after a few seconds, the worm started wrinkling, you know. And then she said to the children, what did we learn from this? And one child answered, well, if you drink gin, you don't get the worms. Which probably technically is true, I don't know. So you have to be careful about factual relationship with where they take you, okay? But the primary scope of the discussion is to establish factual relations between the observation you made. Results on their own are useless. It's only when you build this factual relationship, the result become an answer to your research question, okay? In writing a paper, but in general in doing research, accept the fact that you are not solving a problem forever. You're simply adding a fragment of truth, if you're lucky, to a big picture. The solution will not be given by you. You will contribute to the solution together with many others. It's a humble, ungrateful to many extent job. That's the nature of the beast, okay? Don't extrapolate too much from your little shred of truth, because it makes your result less credible. So if you present a result and you elaborate this in a reasonable way, you're credible. If you take the same result, but you extrapolate from it very far-fetched theory, the entire paper lose credibility, okay? So going back to a visual structure, imagine a paper like a double inverted pyramid. So you start with one title, the largest section is the methods, and then you go down to one conclusion, okay? In my group, we use a Word template that has the skeleton of an IMRAD paper, but also has some notes in red that recall this lecture. You're welcome to download it from this link, okay? And you're welcome to use it. It's my gift to you. How do you handle bibliography? There are a number of reference managers around. I think I use most of them over the years. Recently, we've been standardizing on Zotero. Zotero is free, except for storage, online storage that you use if you are sharing large bibliography with other coworkers. But even the storage is relatively cheap, so it's something you can easily afford. It works very well. I don't have problem. I have to say the only real shortcoming of Zotero is if you don't find a pre-made style for the journal, making your own style it's very tricky. There is no easy thing. You have to edit in a very weird sort of programming language. There is an online editor that helps you to do this, but that's not easy. But the good news is that most of the journal where we publish, there is already a style. So this comes out very rarely. For the rest, it works very well. Of course, there are a lot of alternatives, and maybe your university is offering you something else. It's quite important that in the same research group, you all use the same reference manager, because then exchanging bibliography becomes very easy. One nice thing of Zotero is that it has this web connector that you install in the browser. So when you are in PubMed, you just click and the system creates the entry. And if the PDF, the full length paper is accessible, it downloads and links it automatically. Absolutely fantastic. There is also a web version where you create reference collection that you can access collaboratively. So this is very nice in some, when you do collaborative writing, for example, with other authors. So you have your manuscript. Where are we the time? Let me see. Okay, pretty much. Okay. Where should I send it? That's a tricky question. Okay, that requires a lot of thinking and discussion. Of course, you have to look for a proper forum for your subject. So, for example, a good trick is looking the bibliography of your paper, where all the other papers on the subject were published. If you see that all the debate on that topic has been done in one particular journal, probably that journal is also the right place for your own paper. Okay, so it's a proper forum based on the subject. We are all cursed by these continuous bibliometrics that tune our careers and life. So, of course, impact factor, citation index, these things might matter. Review time. In the old days, this was a huge problem. I mean, I remember I had 2 years for a review in one record publication. Now things tend to be faster, but there are still some journals that are significantly slower than others. So there are situations where you have to finish your PhD, or you want to have that paper out because then you can start to work on the other. I mean, so time sometimes is important. Look also the open access policies. I mean, if your university is not aggressively onto gold access, so that you get funding for paying high fees to the publisher to make your journal, your paper open access, you have to go in green access. And green access is regulated very differently by publishers. So some publishers are very permissive, some other much less. So double check this. We'll come back to open access in a minute. When you have a final version of your manuscript, I suggest that before you send it, you leave it in the drawer for about 3 days, and then you read it again from cover to cover. This helps to resolve the forest and the tree problem, where there is a huge mistake, but you are too close to see it. Even better if you can have a third party read it, someone who is close enough to understand your work, but was not directly involved, is not an author. You can do this as a sort of an exchange of favor. If you have a good colleagues who are working in your lab, on similar topics. You read his paper, he reads your, and that works. Make sure that you respect the rule of authors. Being an editor, an associate editor, and there's nothing more annoying than getting manuscript that completely ignore the instruction for author of the journal. Make sure to always write the cover letter. There are standard styles. It's a convention, but needs to be respected. What about other type of papers? Again, here we go really into personal advice. It might be that your supervisor disagree with me. That's perfectly fine. I usually stimulate PhD students to write a review paper as a first thing in their PhD, as far as that particular topic didn't have a good review paper already published in the last 2 to 5 years. It is a way to document the completeness of your bibliographic research, any consolidated and summarized that knowledge you have on the field before you start to develop your original research. In general, beside this specific case, writing a review paper is a lot of work for not that much glory. So it is something you should do in selected cases. There is a clause, however. Review paper usually gets you a lot of citations. So if you get a very popular review paper, your H index can go up very quickly. Conference papers, I don't know. I'm not a fan of conference paper. I think it's the pain is not worth the gain. In most cases, I think they should be avoided. It might be a way to write and hold the waters around ideas that are not maybe fully ready for prime time, but beside that, I'm not much fond of them. Okay, this is an idea that I always propose in this seminar. I have no idea how many then adopt it, but I love it. So the idea is that you don't write your paper at the end of your research, but you write it while you do your research. So you start by observing a phenomenon, and from this you derive a general question that will be the goal of your research. Well, that's enough to write the title of your paper. Then you start to read the literature, and first of all, you know why this is important, so you can write the relevance section in the introduction. From all the literature you read, you can start to list all the answers, the state of the art, but also you critically review the literature and you identify what are the missing gaps, the things that require further investigation. And then you come to the end of the work, so you know what is your research project. All this can be written before you do the first single experiment. Okay. Once you have fully detailed your experimental method, you can write the material and method, and then you run all your study, your experiment, you run all your model, whatever you're doing, and when you have the results, you go through result discussion and you finish the paper as you finish the study. It doesn't come natural, but trust me, it helps not only to write more quickly, but also to do better research, because sometimes you think things are very clear, and then when you go and try to write on a piece of paper, you realize that they are absolutely not clear in your head. So I believe something is wrong around scientific publishing. This paper was published in 1995, and it was the time when the internet was becoming a big thing. And say, oh, you know, in a few years, a scientific publisher will be dead. The business is dying because the internet will make a scientific publisher not necessary, essentially. Okay, this is a recent article, and it's driven by the fact that companies like Elsevier, this is Relics Group, which is the financial group that control Elsevier. And these are some information about the earnings and the margin, the profit. Okay, these are $1 billion, billion euro. Sorry. So this major publisher are making an enormous amount of money. So not only the business didn't disappear, but they're making embarrassingly high profits. Why is that? Because they managed to create a sort of monopoly. So they control the entire process. And they blackmail our professional community so that we write the paper for free, we review them for free, and then we pay them to get back the reading of our own papers. And that is absolutely crazy. We need to do something about what? Open access. But again, they lobbied the governments, and so the government said, oh yeah, let's do open access with the gold model. You give $2,500 to the publisher so they can let you give your paper around. Come on. So I strongly support open access, but I think that we should start to use much more green access. But we also need to remember two other things. The first is open access for data. Start to share the data that inform your paper. Open access is the future. You will not regret, trust me. Being conservative on these things don't pay in the long run. Put your data on Zenodo, on Figshare, or any other infrastructure that allows sharing of open access data. And here is the trick. Do the same things for valuable illustration. So when you put, you spend 2 weeks to build a beautiful illustration, and you put in the paper, you submit the paper without even knowing you're transferring the copyright of that illustration to the publisher. Some years ago, I wrote a book, and it was somehow the summary of much of my work. So I wanted to use a lot of illustration for my previous paper. You know what? I had to go back and ask the permission to every publisher, and some actually wanted to charge me money for using my own figures into another paper, in a book in that case. So this is crazy. How do you go around this? Well, it's very easy. You, instead of publishing your illustration in the paper as such, you release your illustration in open access with Figshare, for example. And then you reference the figure in the paper as reprinted with permission, like it was somebody else's figure. That way, you're not releasing the copyright to the publisher, and you can reuse the figure where and when you want. Publisher don't like it, so if you do this too many times, probably it might be that the editor write you back and say, we are not very happy with this, but they don't really have a legal argument to contradict you. If you're interested in green access, a fundamental resource is the Sherpa Romeo database. It's a UK resource, but it's worldwide valid. You search on the internet, you write the name of the journal, or you put the ISBN, and it will tell you in detail what are the current policies for that journal. Is there any embargo? Can you publish preprints? Can you publish postprints? All the details you need to know if you want to do a green access, okay? Where do you put your preprints? Well, all the XIV are working. There's ResearchGate. I didn't have very good experience with bioRxiv recently, so I tend to use the more traditional ARXIV, which is the historical one, the progenitor of all. But it's up to you. It doesn't really matter. Okay, these are information only for the student of the University of Bologna. Won't go through this. There are some special services our university provides. Okay, you can read them in the slides. And this also is what we can offer in the university in terms of support for open access data. Okay, again, more information for Unipo. Good. So this is the end of my seminar, which leaves about 15-20 minutes for question, if any. But let me close with this little masterpiece of poetry. Face is a fine invention for gentlemen who see, but microscopes are prudent in an emergency. Emily Dickinson. Thank you very much.
Thank you very much, Marco. Very nice tips and tricks, especially about open access. And I really like the tip about the illustrations. We have some questions. So wait, you don't see me? Now you see me. Okay, the first one is about the transaction. Could you provide a definition of transaction in the context of scientific research? How do transactions differ from regular articles? So I think this is about the first part.
Yeah, I'm sorry. I was probably a little bit stenographic in my presentation. Transactions are not a particular type of journal. I was referring to the transaction of the Royal Society, which is one scientific journal, which happens to be the longest in publication journal in the world, okay? And because it's such an historical journal, frequently we call them just the transactions, okay? But it's just one journal. Transaction, it's just a way, you know, also Tripoli, for example, tend to have many journals that are called transaction of biomedical engineering, things like that. It doesn't identify a particular type of journal, as far as I know. It's just a way of naming journals.
All right. So the second question is, separating the materials and methods section from the result descriptions is more straightforward with experimental studies. But what about papers reporting computational model building? The boundaries of what is methodology and what is to be described in the core, so I think in the results, are sometimes more blur. Any tips or suggestions with that regard?
Yeah, thank you, because this is a conversation that I had like a billion times with my, I don't know if you know, but my own research is primarily computational. So all my team does primarily computational research. So sorry if I sound rude in my reply, but you have to do your homeworks. I agree that it's easier when you're doing experimental research to make this separation, but it doesn't matter. You have to make that separation. Not only because it's necessary to provide a systematic exposition of your research, but in your head, if you cannot separate how you do it from what you got, you have a serious problem. It takes patience, it takes thinking, it's challenging, but it has to be done. There is no corner catting here, I'm sure. I don't have a magic solution for you. It's just painful and you have to go through the pain.
Yeah, I guess we all have to suffer in that sense. Okay, the third question is about organizing your own bibliography. So like using a reference manager. Which strategy do you suggest to navigate large libraries and allow ideas to come up? For example, dividing by topic or by dividing by project, etc.
So I usually have one bibliography with all my own papers. That's more for senior. When you're very junior, that is a very small library, but eventually it grows, and having all your own references at end is very useful. And then I tend to have a database for each paper I write. I don't do project library much. Of course, this means that you frequently replicate references, but that's fine. I mean, you can put the same reference in 3, 4, 5 databases, not a problem. I'm honestly, I don't have any reason to say that this approach is better than other. That's the way I do, but so I tend to build database per paper, not per project.
Okay, that's clear. So we have 3 questions from one person, so I'll go like one by one. Is there any grammar checker you would suggest? Specifically, do you know Grammarly? And if so, do you think it's a good service for scientific writing?
I don't know. I never use it. I thought about this, and eventually I think I should give it a try. For now, I always use the word spell checking. That is very useful for me. I'm a horrible typer, so I tend to produce a gazillion of typos. So for me, it's essential to use a spell checker. And then also the you know, suggestion like the length, the use of the commas tend to be generally correct, not always, but generally correct. But no, I haven't used nothing more sophisticated than that. I'm sorry, I cannot advise on that.
All right. So the second one is, what do you think of having a dedicated contributions section in the within the introduction? So they say they've seen many papers that have this subsection in computer science, especially for proceedings.
Yeah, that the problem is that we don't have interaction with who made the question, because contribution, I suppose you're referring to the section where they detail the contribution of every author to the paper.
I don't know if maybe they can clarify the question while we answer another. The contribution of the study, they say. So what is the particular contribution of this study
to the field?
To the field.
Yeah, but that is somehow in the 4 paragraph I was referring to. So you know, you start and you say, why should we care? Why this is a problem? And you know, I work in biomedical application like many of you, so why is usually a big why. It's about the human life. So motivation is there and it's strong. Then you state whatever everything we know about this, the few things we still don't know, and that comes your question. I think it's enough. I mean, I don't know. I wouldn't see the value of adding that, but you know, maybe I'm wrong.
Yeah, as you said, it's already described in the introduction somehow.
Mm-hmm.
And the third one is, could you say something about the standards for sharing research data? So, for example, you have images that you use for the analysis. If you share them with the others, they might reproduce the results or use them to develop new techniques and so on.
So first, share your data. No matter what, no matter how, no matter when, do it. I know there is this horrible philosophy that, you know, keeping your data in the drawer give you a competitive advantage. Never believe in science as a fight. Science is a collaboration. Anyone who tells you differently is not telling you the whole story. So share your data. How do you share? Well, if there are standards, use them. You know, if you have radiological images, better you share the DICOM files than any derivative because it's full of metadata and it's useful. And everyone can read the DICOM image because it's a standard, etc. But you have to go beyond, and sharing data is not only putting a file on the internet, it requires curation. Make sure you put with the data all the metadata, all the meta information that makes those data useful. And this sometimes requires some thinking and some work, okay? The other thing, see, if you're doing modeling, seriously consider the Physiom journal. It's a new initiative. We are pushing it because we're a strong believer in this. Once you've published your first paper, you can send all your models to the Physium journal. They will try to reproduce your results with your model. If they don't, they will let you know, and there will be an interesting discussion. But if they do, your model will be published in open access, and this will count as an extra publication. And people will cite it. So you will also have a way to measure how many people use your models, okay? So this will contribute to your research career to some extent. Physium Journal, it's an idea of Peter Hunter at the University of Auckland, but a lot of very senior people are in the editorial board across the world.
Okay. So another question about preprints. Is it preferable to publish a preprint, and at which stage of the publication process you usually do that? So like before submitting to a journal or not?
Okay, when you do preprints. The 1 second before you submit. So you prepare the manuscript, you put it on the preprint server, and then you go and you submit it. It has to be identical. You have to put the date in the preprint. You have to put the date where it's being submitted, where. So maybe a minute after, not a minute before. Okay, but contextually. Okay.
Okay. So it's also a legit way to prove that, yeah, if it's a very competitive field, you could say we have this preprint before it's been published and so on. So it's nice.
It's a number of reasons. That's one. The other is that it's not unusual in some communities that have long-standing tradition of preprint that people read your preprint and send you a sort of unsolicited review. They send you and then you realize maybe there is a big mistake, and you can fix it in the first review of the actual published paper, even if the reviewer of the paper didn't spot it. Okay. And so on, and then you keep this alive. So when you do your revisions, when you get acceptance, you can publish the postprint, so the last version of the manuscript that you submit to the publish. But again, check the rule of the journal you're submitting to, because some journals do not allow some of these things, or they allow only after some months from the publication of the article, so-called embargo period. So pay attention. Sherpa Romeo is where you can find all this information.
Okay, thank you. So what do you think of using editing services by the journal you're submitting to? If the paper is free of spelling and grammar mistakes, but just profits from style, does it significantly help acceptance of the paper?
So if you are a non-native speaker and your English is not very good because maybe you didn't have an opportunity to spend some time abroad in an English-speaking country, which I believe is the best way to learn English. So eventually try to organize your life that you spend at least 6 months in an English-speaking country, because that is what you need in your profession eventually. But if you haven't done this, so your English is shaky and your environment is not conducive. So, you know, if you're surrounded by people that are pretty much in the same boat as you, it might be it might be useful. At a certain period, at the very beginning of my career, when in my lab we were pretty much all in the same situation, we didn't have anyone who spoke or wrote decent English. We had a native speaker who was selling us some revision, and it was very useful, because, you know, if your English is very shaky, the comprehension goes down. So the reviewer gets annoyed. Sometimes they don't even understand exactly what you mean. So it's already adding an handicap to your race. Okay. So yes, I think that if you feel that your language is not good enough, you can ask for help. And of course, you have to be very careful, because sometimes the technical writer doesn't understand what you mean. So by fixing it, actually change the meaning. So you have to revise the revision after that. But why not? Why not? I mean, if it's reasonably priced and you can afford, and it's a good service, why not?
Okay, good suggestion. A small question: which word processing program do you suggest? Word, LaTeX, etc.
I've never been. I think I did my master thesis with text, and I think I have a PTSD syndrome. The trauma was so high that since then I never wanted to use LaTeX anymore. I hate it. So I use Word. Microsoft Word, very boring, not fancy, not very engineering, but it works for me. I have a paid equation editor, which is slightly better than the standard Word one, because I do sometimes some very mathematically heavy, so that's I think it's called math type, but that's it. I don't use. I know. I mean, I have some very good friends who use only LaTeX, and I see the advantage. So you can copy and paste. There are a lot of benefits, but there's also a lot of overhead. I don't know. It doesn't work for me. But
Yeah, I guess this is like a very personal choice also.
Yes.
Also, it depends on the co-authors, you need to share the document in the end with someone who's going to edit it. So, yeah.
Yeah, that's true. In fact, in a few cases in the last 10 years, I had to work with LaTeX because I was simply contributing to a paper that is being written by somebody else. At that point, you don't have choice. You have to use whatever they used. Yeah.
Yeah. The last question I have is, thank you very much for the interesting talk. I would like to know how to write the same manuscript for different journals. So a computational biomedical study, let's say, and you send it to, you want to try different journals. You need to make major edits between different journals.
So I hope you're not suggesting that you're trying to publish twice the same work, because that's not a good thing. It's bad, and nobody should do it. So I suppose the question is, if you prepare the manuscript for, I don't know, Journal Biomechanics, and then for whatever reason you want to submit that manuscript to JBJS, of Journal of Orthoplasty, Journal of Orthopedic Research, a more clinical journal, how do you change it? Writing is communication. Communication is all about the audience. So you always have to ask to yourself, who is going to read my paper? And from that, you understand that probably some details become not so important. So, if you're a classic problem, you're explaining engineering work to a doctor, okay? It's not that the doctor will sit down and try to replicate your study using ANSYS. This is not going to happen. So some of the details can be skipped. On the other hand, however, the doctor might have a much more deeper insight of the use of some result and the clinical implication of some result. And that's the element where you need to work and pay more attention. It's always about the audience. This the same when you're doing a scientific presentation. I mean, you have to tailor your message to the audience.
Yeah, and also some of the journals, they have a different layout, let's say. So some, for example, require methods right after the introduction, or some require.
Of course. And then you change journal, you change instruction of authors, and you have to respect the instruction of authors. You know, some have the so-called structured abstract, where the abstract have subheadings. You know, material methods. I found it weird, and not particularly useful. But you know, okay, fine. You have to follow the rules. I mean, that's the way it is. I agree.
And that's actually the end of the questions. Thank you very much again for this very useful webinar. And yeah, the audience will receive the email with the link to the recording and also the slides. So, and in the meantime,
thanks to you and thanks to all the audience. As I was saying at the beginning, we are discussing with the leadership of the VPH Institute whether to make this a sort of a recurrent appointment every year or so. So if you found this useful, if you think that it would be worth to have this repeated for other students in the future, please write to Zeynep and to myself and to Lisbeth Geris, the director of VPH, expressing so that we know that this actually would be a desirable thing for our community. Okay.
Federica, could you share the email address once again in the chat so that everybody has it? And then I think we can close the session. Thank you everyone for attending. I hope you enjoyed it. And yeah, see you in another VPH Institute event, hopefully.
Thank you. Bye-bye, everyone. Have a good day.
Bye-bye.